Hi everyone, welcome to your very first lecture video, which covers Chapter 1, Introduction to Statistics. In this video, we will be covering a variety of topics, starting off with the actual definition of statistics and the broader role that it plays within our overall research process. We will also be talking about the difference between independent and dependent variables, as well as the various levels of measurement that statistics can be measured at, so both the nominal, ordinal, and interval ratio level. We will also define the difference between descriptive and inferential statistics and how that has implications for our research questions. And lastly, we'll briefly be going over the differences between univariate, bivariate, and multivariate analyses. So to kind of kickstart our conversation into this first chapter is this question right here. Why should we study statistics? And for me, and I'm sure most of you as well, you're probably asking yourselves why you're in this class to begin with. I remember when I first signed up to be a criminology and criminal justice major, statistics and research methods were two of the classes that I didn't even know I had to take when I signed up. But I think it's important for us to contextualize this in a broader sense of why we both as a department and a university feel like this is an important class for you all to take, but also how it can be applicable to you all in your broader studies of criminology and as you move forward into an eventual profession. And so, again, starting off with this question, why should we study statistics? Overall, it helps us understand and analyze our own trends within data, and it also allows us to have a variety of applications within social science, and it's critical for us to understand social phenomenon through being able to communicate various aspects of our data. And so in other words, our actual description and definition of statistics is a set of procedures that organize, summarize, and communicate numerical information. It also involves the collection, organization, and analysis of data. And next, we're going to look at a couple different forms that you can communicate just that. The first type of graphical information that we're going to be covering is called a cartogram. And what you're looking at here in this slide is a cartogram that displays the level of felony disenfranchisement by state throughout the United States. And we can see here in the bottom right-hand corner is our color gradient, which is demonstrating to us the different percentages in which the population is experiencing felony disenfranchisement. So recall that felony disenfranchisement is the phenomenon that once you've been convicted of a felony, there are a lot of collateral consequences that derive from that conviction. Oftentimes that includes revoking your right to vote. Other types of instances include checking a box on an employment application, or even things like a rental application for a lease as well. And so what this cartogram is demonstrating to us here is that as the purple gradient increases in color, so as we get more purple as we move down the chain here, the higher percentage of the state's population has been disenfranchised. And so what this specific graph is showing us is that this southern region of the United States experiences higher levels of felony disenfranchisement in comparison to other regions throughout the United States. What this also shows us is that with our deepest color, purple here in the bottom, is that Florida is uniquely experiencing a very high level of felony disenfranchisement, upwards of 10%. And so what this allows us to do is to both communicate statistics in a way that might be a little bit more legible to a broader audience, but also shows trends and patterns that are happening across the United States as well. A second and more common type of graph that communicates statistical information is a line graph, and this one should look pretty familiar to us. But what's important to note about line graphs, or really any graphs in general, is to look at all of the axes prior to interpreting any of the information that you may see in the graph itself. So in this case, our y-axis here on the left is communicating to us the various percentages in which there has been support for stricter gun laws. Our x-axis here at the bottom is showing us the various years in which this survey was conducted. And that ranges all the way from 1989 here on the far bottom left-hand side to 2019 here on the far right-hand side. And what this allows us to show is trends over time. So how has support for stricter gun laws changed over the last 30 years? What's also interesting about this particular line graph is that we have a variety of colors that are showing us different levels of support as well. So here at the top in the red, we have support for more strict gun laws. Here in the middle, we have that bluish black color of keeping the same types of laws that we currently have in place. And lastly here, the green at the bottom is that we should actually have less strict gun laws. What's also fairly interesting about this graph as well is it shows us different time points with respect to broader societal ills that were happening with different shootings. And so in this case, we see the Columbine shooting just prior to 2000, the Sandy Hook shooting, and the Parkland shooting. And so what this shows us as well is how did those specific events also affect support for gun control? And in this case, we can see that more strict actually went down quite a bit after the Sandy Hook shooting. And so there's kind of this precipice that is happening after time. And so as researchers, something that we can do is try and investigate further once we can track these trends over time of why this might be happening in the first place. And so that's something to keep in mind as you see graphs both in your daily life and throughout this course. And perhaps the most common type of statistical chart that you would see communicate information is what you see displayed here on this slide, which is commonly referred to as a bar chart or a bar graph. But before we dive into the interpretation of these two particular charts, I want to give you a little bit of background information about this study. Reason being, we're going to use it to both interpret these charts as well as have a broader conversation about the overall research process. And so with that being said, this study, which was entitled The Mark of a Criminal Record, was published by Dr. Deva Pager back in 2003. And her primary research question and research interest really revolved around this idea of felony disenfranchisement, which is what we saw in our cartogram a few slides ago. And so in this case, her research question was, how does one's criminal record affect their likelihood of getting a job callback? And so essentially her idea was, how does a criminal record affect employment opportunities in the future? And she studied this in two primary ways. One is she looked simply at whether or not someone received a callback, and second, whether or not this varied by race. And so to give a little bit of broader context about this study, the way that she went about this was twofold. First, she had 4 testers, 2 of which were black and 2 of which were white, apply for over 350 entry-level positions. When she did that, though, she had one of the white testers and one of the black testers also indicate that they did have a criminal record in their resume materials. And so what we're looking at here in figure 5 first is this idea of how did a criminal record affect one's ability to get a callback? And we know this because we can look at both our Y and X axes to give us that information. In this case, our Y-axis is showing us the percentage that were called back, and this ranges from a percentage value of 0 to 40. And what we're looking at here is in this dark black bar is that 17% of individuals who had a criminal record did receive a job callback. In comparison, those that did not have a criminal record had a 34% callback rate. And so in this case, it was double. So what Deva Pager was able to show in this case is that you had twice the likelihood of having a job callback if you did not have a criminal record. And so we can see a clear effect here in this black bar that a criminal record severely impacts your ability to acquire a job callback and affects your future employment opportunities. In the very next figure in this study, though, she also disaggregated this by race. And so not only is she looking at criminal records, so whether someone had one or not, but did this vary among her white and black applicants? And in this case, we see that it does have a very severe effect as well. 34 percentage points of those individuals that were white that did not have a criminal record received a job callback in comparison to only 5% of individuals that were black that had a criminal record. So not only are we able to see the effect of having a criminal record here on our left-hand bar chart, but we also see how that can have differential racial impacts as well. So let's use Dr. Pager's study to have a broader conversation about the overall research process. And the first step that we have to do with any type of research project is actually establish what we're interested in and what questions we are going to ask. In this case, Dr. Pager was interested in the idea of how do criminal records affect employment, and she measured this via the percentage of callbacks that those applicants received after they applied for those entry-level positions. To actually figure out how we would go about conducting this study, we also need to reference theory. So if you've taken the criminological theory class in the department, that's where that step comes into play. And so what theory tells us in this case is that criminal records might prevent employers from calling job candidates because they discriminate against them, or they might actually have policies company-wide or actual laws on the books that prevent them from hiring those individuals. At this step as well, we also want to determine what our dependent and independent variables are. You can also think of these in terms of cause and effect language. In this case, our dependent variable is job callbacks. That's what we're measuring overall. So again, what percentage of those applicants received that job callback? And if you need to, go back a couple slides to take a look at those bar charts to reference that there. But again, what we're taking a look at in this case is what may cause that percentage to change. In this case, Dr. Pager believed it may be an individual's criminal record, but also that it might be the race of the applicant themselves. So again, what might cause the percentage of job callbacks to be different between these applicants? And in this case, she's theorizing that it may be one's criminal record or their racial identity. So let's keep that in mind, and we'll hit that again in a couple more slides. Moving along with this research process, though, is once we establish our research question and we take a look at theory as well, we can actually formulate our hypotheses. In this case, Dr. Pager hypothesized that criminal records would lower the chance of callbacks from entry-level positions. So once we actually formulate our hypotheses, we can go about actually testing this to see if we were correct. Was our idea about the effect of criminal records shown within our data, or was it not supported? And so that's where actually collecting the data comes into play. And if you recall from a couple slides ago, we discussed how Dr. Pager went about this. She had 4 testers that she utilized within her experiment. 2 were white applicants and 2 were black applicants, and she also varied that by their criminal records. Even though that wasn't necessarily true, she was still controlling for that so that she could see what effect that may have had. And so in this case, when she's collecting the data, she is looking for that percentage of callbacks that the job candidates had both with the criminal record and without it. Our very next stage, though, is where statistics comes into play. So once we've asked our research question, we've consulted with theory to formulate our research hypotheses, and now we've collected the data. Statistics is our data, so we have to analyze it. And in this case, that's where that bar chart comes into play. What Dr. Pager could have done, but it wouldn't have been as nice for us to be able to actually interpret it, is just give us an Excel-style spreadsheet of those that got callbacks and those that didn't. But as a reader, that's not the best way for us to actually interpret and analyze information. And so that's where these bar charts and bar graphs can really come into play and really help us as a reader understand the broader implications of the study. And so once we collect the data, we can analyze it, and then lastly, evaluate it with respect to our original hypotheses. And so if you recall, the original hypothesis that Dr. Pager had was that criminal records would have an effect on these percentages of job callbacks, and her hypothesis was supported in this case. In this case, the criminal records did lower the overall percentage of job callbacks for those individuals that indicated that they had a criminal record. So let's tease out this idea of independent and dependent variables a little bit more. If you've taken the research methods course within this department, this should look pretty familiar to you, But if it's not, let's go over this together with respect to Dr. Pager's study. In this case, a dependent variable is the variable the researcher wants to explain, or the effect. You can generally look two places for the dependent variable, and that's the original research question as well as the hypotheses. In this case, the researcher was interested in figuring out the percentage of job callbacks that these individuals would receive, and she was doing that to measure their ability to get a future job opportunity. She was also interested, though, in two independent variables, or what might cause the percentages to be different between those applicants in terms of their ability to get a job callback. And in this case, there were two independent variables that she was interested in. The first was whether or not there was a criminal record indicated on the application. In this case, recall that she had one white applicant indicate that they had a criminal record and one black applicant indicate that they had a criminal record. So this is what may cause there to be a difference. The second independent variable of this study was also race. So the first, again, was whether or not they had a criminal history, and the second is whether or not this varied by race. So we have two independent variables in this study. And that can really depend on what you're looking at too. So keep an eye out for that as we move through this semester and in any future journal articles or other things you may have to read for class as well. So again, overall, our independent variable are those that may cause an effect on our dependent variable. Now that we've defined the difference between independent and dependent variables, it's also important for us to understand the various levels of measurement that we can utilize to measure our independent and dependent variables. So let's first define this. Levels of measurement are the classification of data based on the properties of the numbers assigned to the variables. And I know that may seem a little bit abstract, but the reason that we need to define a level of measurement is so that we can determine the types of statistical analyses that we can use to measure our data. And there are three types that we will be discussing in this course. The first is nominal, the second is ordinal, and the third is interval ratio. With this third category, you may see it different in your book, or if you look up this online as well, you may see them parse out both an interval level of measurement as well as a ratio. For the purposes of this class, we are going to collapse this category into one. So the only three that you need to be aware of, again, is nominal, ordinal, or interval ratio. So let's start by discussing nominal level variables. In this case, nominal variables are those that have scores or categories that are not numerical and they cannot be ordered. In other words, if we change the order of the responses, it doesn't affect our overall interpretation of them. So let's take a look at this bar chart on the right-hand side of the slide so that we can kind of see what this looks like in action. If we were to conduct a survey asking the people in a class at UMSL if they are a morning person or not, and we received 6 responses that say, no, they're not a morning person, 4 that say, yes, I am a morning person, or 1 saying, I don't know, I could be either. A couple things to notice here on our x-axis. Our x-axis here only has non-numerical categories, so you don't see any numbers. It's not like we're asking them on the survey, how many times did you wake up in the middle of the night? 1 time, 2 times, or 3 times, right? It's just a yes or no answer. Additionally, if we change the order of these bars, it doesn't affect our overall interpretation of them either. If I switched these bars to be displayed where the no went in the middle bar and yes went on the far left side, that would still make sense to us. We would just move this 6 bar here to the middle and this 4 bar here to the left-hand side, and it wouldn't make a difference for our interpretation at all. A second level of measurement that we will be discussing is ordinal level variables. Now, ordinal level variables are those that do have categories and they can be ordered in a certain way, but there is not necessarily a direct scale between them. So let's use this example here on the right-hand side to illustrate this particular level of measurement. In this case, survey respondents were asked the question, what is the highest level of education that your mother has received? And they had 5 options to respond to. less than high school, meaning that their mother did not complete it, high school grad, meaning that they did receive a diploma. Some indicated that they may have gone on to some level of college training, but they may not have actually received a degree. College graduate indicates that they did receive and complete college. And lastly, graduate indicates that their mothers did attend some level of graduate training. What this shows us on our x-axis here is a scale that orders these 5 categories from the least amount of education to the highest level of education. Now, theoretically, we could reorder these bars and mix them all up, but it wouldn't make the most sense to us to put graduate level education here on the second bar and move high school grad to the 4th, right? We want to make sure that our statistical information is as readable so that we can both communicate that information to our readers and our broader audience, but also this allows us to see some trends as well. And so if we were interested in learning about the level of education of our mothers in our statistics course, maybe it shows us that we'd have a trend if we were to conduct this among our own students, that it might look something like this, that a lot of UMSL students have individuals in their lives, particularly their mothers in this case, that have received a lot of education. However, if we mixed up all of those bars, we wouldn't be able to see that there might be a trend at play here. In contrast, we also have interval ratio level variables, and this is the last type of level of measurement that we will be discussing. As a reminder, your book may differentiate between both interval level variables and ratio. You might also see this if you look for additional materials online. But again, for our purposes, we are going to be collapsing these into one category. And so the difference between nominal, ordinal, and now interval ratio level variables is that interval ratios are those that actually do have numeric values. So this is different from both our nominal and ordinal level variables that we have discussed up to this point. Not only do they have numerical values, but they can be ranked in a way in which the distance is known. Units also have to have equal intervals, meaning that each of our bars are going to be equally distributed, so it's going to be the same amount in between each of those. And we have to have a 0 point as well, meaning that 0 has to be one of the numerical options here. In this case, let's take a look at our example here on the right-hand side of this bar chart that asked survey members, how many hours do you spend on social media per day? So, as we have with all of our charts up to this point, let's first take a look at our X and Y axes. So again, our Y-axis up here is looking at our number of respondents. So in this case, how many people did we ask these questions to, and what were the number of responses to each of these categories? Our X-axis here at the bottom is displaying the number of hours that a respondent indicated they spend on social media per day. So let's take a look at this. In this case, we had 3 individuals who said they don't spend any time on social media per day. We had 4 individuals indicate that they spend about an hour each day. Second, we had 9 people who indicated that they spend about 2 hours. Then we're back down to 1 individual saying about 3 hours and 3 individuals saying about 4 hours. So again, what we can see here and kind of determine some of the trends and what we'd want to communicate to our reader here is that most people on average are spending about 2 hours a day on social media, at least within this particular sample. Now that may vary depending on who we're asking. So it's always important too to indicate what our sample is and how that may affect our overall data. So in this case, we kind of have a bell-shaped curve, which is a real nod to our Chapter 5 material on the normal distribution, which we'll be getting to later on. But on average, again, our average score here is 2 hours per day. Again, we had the most respondents indicate that they spend that amount of time, and we don't see as many individuals on these extreme values. So both we have less people who spend only about no time a day on social media, and we have about the same amount of people who spend quite a bit of time, up to 4 hours on social media per day. Also, what's important to note is on our x-axis here, what we're discussing here about the distance between the values being known is that we know that each interval here is the difference of 1 hour, and it's equal between each of these as well. So we know the difference between someone who is spending 0 hours per day to 1 hour per day is the difference of 1 hour. Same when we go from 1 hour a day to 2 hours a day. It's still the difference of 1 hour. What you would not see on an interval ratio level is us start here at 0 and then jump all the way to 5 hours per day on this middle bar. You need to make sure that the scale you're using on the x-axis down here has equal components between each of those bars. So keep that in mind as we're working through each of these levels of measurement, both in the context of this PowerPoint and your homework sets moving on. Now that we've discussed the broader research process, we've talked about the difference between independent and dependent variables, as well as how we can measure those with our various levels of measurement. Let's talk about our two broader categories of how statistics can be categorized. The first is called descriptive statistics, and the second is called inferential statistics. Descriptive statistics are those that refer to the statistical methods we use to summarize, organize, and describe data, either from a sample or a population. The key word here for descriptive statistics actually pops up twice on this slide. It's the word describe. So not only does it describe data from a sample or a population, but it also focuses solely on describing the visible characteristics of the data collected. And so the examples I showed you for both nominal, ordinal, and interval ratio level variables, all those charts we saw on the right-hand side, are examples of descriptive statistics. All that we're doing there is simply describing the data that we collected ourselves. So from those surveys, what were our results? In contrast, inferential statistics are those that use a set of methods to make inferences or generalizations about a population based on data obtained from a sample. So a couple key words here on this slide to note, the first being inferences, right? We are using inferential statistics to make conclusions or generalizations on a small sample, but then extrapolating that up to a broader population. So let's talk about how that might actually be utilized. When we use descriptive statistics, those can be especially helpful when we have a small population or a small sample. In this case, for both our nominal, ordinal, and interval ratio level variable examples just a few slides ago, we simply used survey responses. And so that encapsulated an entire class or an entire university, right? But sometimes we also like to make inferences when it's not necessarily usable for us to be able to survey every single member of a population. And a prime example of that is when we look at polling in presidential elections. And so it's unreasonable for a pollster to be able to survey every single person within a state or even a county, but especially the entire national level of the United States, to kind of figure out where the pulse of the country is. Who are we interested in voting for? That's the idea behind polling. But in this case, again, it's not feasible for us to be able to ask every single person what their opinion is. And so the job of pollsters is to make what's called a representative sample. So they're trying to mirror different demographic characteristics, whether it's race, gender, socioeconomic background, to try and get a sample of the United States that may be representative of the entire population of the United States. So they may be able to survey about 1,000 people, and they can extrapolate that up, meaning that they can use that sample to make inferences about how the entire country may be feeling about a particular presidential candidate. So in this case, this type of statistics is also used in hypothesis testing because, again, we have a certain idea about a research question and we want to know if our hypothesis is supported or if it's not. And so that's important to keep in mind here. But again, keywords with inferential statistics is that we're using a smaller sample to make inferences about a broader population. And we typically use those again in scenarios where it's not feasible and we can't really survey every single person that we want to. There are 3 different types of analyses that we will be discussing to conclude our first chapter discussion. The first is called a univariate analysis. The second is a bivariate analysis. And lastly, a multivariate analysis. Let's first discuss what a univariate analysis is. In this case, this is the simplest form of data analysis that we can use because we're only analyzing one variable. In this case, if we take our pie chart example here, all that we're analyzing is the amount of pie that we've eaten, right? That's our only variable of interest. You can also take a look back at some of the examples we used previously that are univariate, which is how many hours do you spend on social media per day, right? There's only one variable we're interested in there, and that is how many hours you spent, and in this case with the pie, how much pie have you eaten? The second is bivariate analysis. And in this case, this is where we're looking at analyses of two variables simultaneously to determine whether there is an empirical relationship between them. So in this case, the example we're looking at here is the number of hours that someone spends studying for a particular exam, and then what their test grade actually shows. So variable number 1 is how much did you study, and variable number 2 is what grade did you receive. So in this case, what we're able to see with our bivariate analysis in determining what type of relationship we see is that we see a trend line forming here in which the more hours that you study, the more likely you are to have a higher overall test score. So in comparison to univariate analyses in which we're only measuring one variable, bivariate analysis allows us to start forming trend lines because we can see the relationship between two different variables. And lastly, multivariate analyses are those that involve the examination of more than two variables. So this is where we're differentiating out between both our univariate, which looks at one variable, and our bivariate analysis, which looks at two. So now we're looking at least three variables. So let's take a look at our chart here on the right-hand side of how this illustrates a multivariate analysis. The first thing we'll do, as we have with all of our charts throughout this lecture, is first identify what variables are on our y and x axes. So I'm going to label those here. Another helpful thing to take a look at, if you were to look at this in a journal article or maybe a newspaper clipping as well, is the title of the chart itself. That's where a lot of key information is going to come from. So in this case, what we're looking at here is the number of vehicle stops that resulted in an arrest by race or ethnicity in the year 2015. And so on my y-axis here, I am first looking at the number of vehicle stops that resulted in an arrest. So that ranges from a 0 value down here on the bottom of my y-axis to upwards of 500 on the top of my y-axis. What I'm looking at here are 12 ticks that represent each month of the year 2015. So our variable in this case is the year. So this is specific to this year only. And last, we are also looking at how this may be different for each racial category. So in this case, our light blue bar is representing our Hispanic population. Our gray bar is looking at our white population. And our dark blue bar there is taking a look at our Black population. In this case, let's identify each of these three variables so that we can illustrate what a multivariate analysis might look like. In this case, our very first variable is the number of stops that resulted in an arrest. And that's actually told to us in our title here too. So not only can we use our y-axis to indicate that, but also our title is telling us that as well. Our second variable of interest is race or ethnicity, and that is designated to us down here by the three different bars that we have listed here as well. And our last variable here is the exact year that these researchers were interested in. In this case, it was the year 2015. So not only are we able to track the number of stops that resulted in an arrest, the race of the individuals that affected, but also each individual month within a given year. So those are our three variables. We have 1, the vehicle stops, 2, race and ethnicity, and 3 is essentially time, or what year and what months is this occurring. And so that's where we get into more information that we can use to identify trend lines over time. So maybe there is a particular dip, and in this case, we do see that for all three racial categories, September, for whatever reason, has a decline in the number of vehicle stops that resulted in an arrest. And so as researchers, something that we can do with this information, now that we've charted it out and we've identified this pattern, is go look into why that may be occurring in the first place. What is it about the month of September that resulted in this decline for all racial groups? Perhaps did law enforcement change their patrolling patterns during that time? Did a new recruiting class come in? That's where the research process and research cycle starts over and over. And it's a cyclical process. So once you have the answer to one question, it oftentimes generates a lot of follow-up questions as well. And that's the beauty of research and using statistics to answer questions that we may be interested in learning more about. So as we conclude your first chapter lesson of chapter 1, these are the types of questions and topics that you should now be able to successfully understand and be able to articulate back now that you've concluded this video. So what I would recommend doing in preparation for both your first problem set as well as your first quiz is sit down with this summary slide now and ask yourself, am I able to answer each of these questions? Can I define what statistics is and the role that it plays in research? Can I identify the difference between independent and dependent variables? This is something that I will ask you to do on your first problem set. Another aspect that we covered is the different levels of measurement. And so can you identify correctly different levels of both nominal, ordinal, and interval ratio level variables? We also covered the difference between describing our data and using it to make inferences. And lastly, we just followed up with our last aspect here of univariate, bivariate, and multivariate analyses. And so again, what I would recommend doing is going back through each of these and making sure that you can answer each of these adequately. You'll also be able to get a good gauge on this as well as you move through your first problem set. And if you have any trouble with any of that, that would be a great indicator to either send me an email or stop by my office hours virtually or set up an appointment with me as well. So again, if you do have any questions about this material, please feel free to reach out, and I will see you in the next video.